My name is Augustine Awafu, one of the authors of the paper titled A Sustainable Rural Electrification of Morocco Using Stevia Biomass Power Generation, Lessons for Paraguay, ID number 9123. In this presentation, I'll be looking at my introduction, problem investigation, the results, and then conclusion. So in my introduction, there is a over-reliance of the energy sector of many developed and developing countries on fossil fuels to satisfy their growing energy needs. And if you look at Paraguay and Morocco, they are noted to derive greater share of their energy from fossil imports. And there are challenges that comes with fossil power generation. Some of these challenges are high carbon emission, we have price fluctuation of fossils, depletion nature of fossils, and then the high import bills associated with fossil power generation. And for us to shift from fossil power generation, we must look at alternative energy solutions, which renewable power generation can be an alternative to fossil power generation. Now, renewable power generation, we'll have several sources of renewable power generation. We can talk about solar, wind, biomass, tidal, and geothermal. But if you look at among these renewable power generation sources, biomass power generation is very ideal when you look at the context of the Paraguay and then Morocco energy sector, because of the abundant nature of biomass that is produced in these countries. And biomass, we have first generational biomass, we can talk about second generational biomass, and then the third generational biomass. And the first generational biomass, which are the energy crops like the cassava, sugarcane, and then we talk about the second generation, that is crop residue, food waste, and animal remains. And then the third generation biomass, we can talk about algae. Now, my problem investigation. In this study, we are using Bertoni biomass for our power generation. And in the study, we look at the heating value estimation of the biomass from Bertoni using the formula. The lower heating value is the higher heating value, and then taking out the moisture content from it, that is the 1 minus the moisture. By this relation, we can have the lower heating value, which we use in the energy estimation. And once we have the lower heating value, then we can do the energy estimation using this relation. And then we can also do the electric power potential estimation using the relation for the electric power. And this one, we use the energy that we estimated with the plant operation factor. Now, in this study, we use the combustion process for our power generation. So we feed in the dry leaf into the combustion chamber, and then you have the boiler or the furnace that will heat, and then the steam is now coupled to a turbine, and then the turbine is coupled to a generator that will generate our electricity. In this study, we try to do the estimation for various type of the biomass, different type of the Bertoni crop, and then we use 3 different varieties. We have the Gawi, the Suhai, and then the Pop Inra Bertoni types. And then we look at different regions in Morocco, like we have the Agadir, Berkane, Lariche, Marrakesh, Rabat, and then Sefro. So in these areas, we tested the energy generation potential for all the varieties, and if you look at it, all of them had high electric power generation potential, as you can see. Now we try to do the electricity generation from each of them. So these are the electricity generation that we can have using each of the varieties of the Bertoni that we have, as we can see in this figure. Now we try to do the electricity capacity generation, and then also the emission content. And then for the areas that we consider in the study, so these are the areas that we try to do some HOMA simulation to see the emissions and the electricity power that can be generated. So these are the electricity generation capacity, the area of cultivation, and then the carbon emission. So if you look at this carbon emission, it's considerably low as compared to fossil power generation and other traditional power generation sources that can be used. So in conclusion, this current study has examined the potential of electric power obtainable from dry leaves of betony as a novel feedstock in agricultural sector. In this study, the potential of energy production from betony in 6 suitable areas was assessed. The outcome of the study indicate that the pulp area has the highest energy potential, and then it is suitable for power generation in Morocco. Thank you.